Welcome to today's tutorial. In our tutorial today, we're going to look at a question that's coming from Kinematics. And the question reads, the diagram shows the speed time graph of a car during a period of t seconds. So we're able to see the diagram here showing the movement of a car from 0 to 9 meters per second in 8 seconds. Then it maintained with a constant speed for 6 seconds, meaning from 8 to 14. Then it had to retard to t seconds. So the question is saying, find the acceleration of the car during the first 8 seconds. Now, if you look at the first 8 seconds, this car was accelerating. It is moving from 0 to 9 meters per second in 8 seconds. So therefore, if you are to carry the data there, you are to carry the data for question A, we want to find the acceleration. Okay, the initial velocity there is 0, and the final velocity, that is 9, and the time taken for this car to accelerate is 8 seconds. So we know the formula is acceleration is equal to final velocity minus initial velocity divided by time. So our final velocity being 9, our initial being 0, then divide by 8 there. So 9 minus 0, the answer is 9, then there over 8. So you can say the answer is 9/8 meters per second squared. That's the answer for the A. We continue. B, the question says the distance covered in the first 14 seconds. Now, if we are to look at the shape that we're having in the first 14 seconds, that is a trapezium, of which we are told that from there to there, this represents the height, which will be 9 here. Then from the 0 to 14 there, this is the base, which is 14. And from there to there, this is the width, which represents 6. From 8 to 14, it is 6. You subtract 14 minus 8. Now, we are told that distance under a graph, take note, the distance under a graph is equivalent to area of a given figure. So the figure that we have here, it's a trapezium. So that basically tells us that distance here is going to be equal to half A plus B, then multiplied by height, where we shall say half our A, that is 6, our B, that is 14, then our height, that is 9. So that's going to be 1/2 multiplied by 6 plus 14, that is 20, multiplied by 9. So therefore, we can say that distance in the first 14 seconds is equal to 90 meters, meaning half multiplied by 20, then multiplied by 9, we're going to get 90 meters. Okay, we continue. We look at the last part, which is a C. See, the question says, find the value of t if the average speed of the car is 7 meters per second. Now, we are told here that the average speed is 7 meters per second. Now, for us to find the average speed, we'll say it is total distance covered over the time taken. So we need to have the total distance of the whole journey, of which this total distance, it's going to be the distance that we have found in the first 14 seconds, and then the distance also of this other part, which I'm shading in red, okay, which is also a trapezium. Now, it being a trapezium, it means that this is going to be its height, because the height is always opposite the slant length. So if that will be the height, that means this height will be t minus 14. Then this, which was the height for the other side, it's going to be the base as a 9. This is going to be the width, which will be the AB equal to 7, like that. Okay, so if that is equal to 7, then we can say the area of a part that was shaded in black and the area of a part that was shaded in red, if you add, is going to give us a total distance. So the first thing first, we need to have the total distance of the whole journey. So how do we do that? We are going to say that total distance of the whole journey, okay? So total distance covered is equal to the area of the first trapezium, which was in black, plus the area of the second trapezium, which was in red. Okay, so there we shall say 1 over 2 multiplied by 6 plus 14, and our height was 9 there. The next one, 1 over 2, where we had the 7 plus 9, and our height there was t minus 14. Okay, so 1 over 2 multiplied by 20 multiplied by 9, and here we're going to have 1 over 2 multiplied by 16, then multiplied by the t minus 14. Okay, 1 over 2 multiplied by 20 multiplied by 9, that's going to give us a 90, which we found in the previous question. Okay, then 1 over 2 multiplied by 16 there, we're going to have 8. Now this 8 is multiplying everything that is in the brackets. Okay, so 90 plus 8 multiplied by the t there. Okay, that is going to give us 8t, and 8 multiplied by 14 there is going to give us 112. Okay, then we'll put the like terms together, where we shall say 8t minus 112 plus 90. Okay, therefore we're going to say that the total distance covered is 8t minus a negative 112 plus 90 is going to give us 22. So meaning the total distance covered is 8t minus 22 meters. Okay, so once you have your total distance, therefore we can say that average speed is equal to the total distance covered total distance covered, divide by the time taken. Okay, so if you look at our diagram there, the time taken for the whole journey, that happens to be the t. Okay, that happens to be the t. Then we are told that the average speed is 7 meters per second. So we'll go back and fill in this formula where our average speed is equals to 7, being equal to our total distance covered. It is 8t minus 22 over our time taken, that is t. Okay, what do we do at this stage? You cross multiply, which we're going to say that 8t minus 22 is going to give us 8t minus 22 being equal to 7 multiplied by t. That's going to be equal to 7t. At this stage, you put the like terms together. So we are told that whenever a number crosses the equal sign, the sign of operation changes. If it was a negative, it's going to be positive. And if it was a positive, it's going to be negative. So we shall say 8t minus 7t being equal to, when the 22 crosses the equal sign, is going to be a positive. So 8t minus 7t, the answer there is going to be t being equal to 22 seconds. Okay, so that is the value of t in our question.